Welcome to CBS Easy.
Hey everyone, does the word trigonometry in Chapter 8 make you a little nervous about your board exams? Yeah, I get it. But you're in exactly the right place. Stick with me for the next few minutes and we're going to build a simple, powerful plan to help you absolutely master the basics.
Okay, let's kick things off with a classic puzzle. How in the world would you measure the height of the Qutb Minar without, a ridiculously long measuring tape? Well, the answer isn't magic, it's math. By just standing back and looking at the top, you create a simple right-angled triangle. And with that, you can calculate that massive height using a powerful tool called trigonometry.
So, here's our game plan. It's a 5-step roadmap to get you totally exam ready. We'll start with why this stuff was even invented, then learn its core language. After that, we'll zero in on the most important angles, uncover a secret link to Pythagoras, and finally, build your master plan for the exam.
So really, why do we even need trigonometry? Well, it was born from a very simple need, to measure the impossible. Think about it. How do you measure the height of a mountain, the width of a river you can't cross, or the distance to the moon? You can't just use a ruler. You use triangles.
The name itself is actually a dead giveaway. Tri means 3, gon means sides, and metron means measure. So at its very core, trigonometry is just the study of the relationship between the angles inside a triangle and the lengths of its sides. That's it! It's this amazing tool that connects them.
Okay, let's learn the language of triangles. And here's the good news. To speak it fluently, you just need to know a few key words. We call them the trigonometric ratios, and we're going to start with the 3 most important ones right now.
Now, before we even get to the ratios, this is the most important rule, so listen up. Your perspective matters. The hypotenuse, that's always the longest side, opposite the right angle. Easy. But the opposite and adjacent sides, they totally change depending on which angle you're looking from. For our examples, we're going to be standing at angle A.
All right, our first ratio is sine, which we just write as sine A. It's simply the ratio of the side directly opposite your angle to the hypotenuse.
Next up is cosine, or cos A. This one connects the side that's adjacent, or right next to, your angle, with the hypotenuse. And finally, we have tangent, or tan A, which is the ratio of the opposite side to the adjacent side. Now, these 3 are your main building blocks. And hey, just so you know, they each have a reciprocal partner, cosecant, secant, and cotangent, which are literally just these fractions flipped upside down. But for now, let's just master these 3.
Okay, 3 ratios, 3 formulas. How are you going to remember all of that in a stressful exam? Simple. You use this one powerful phrase, so, ka, toa. It sounds like nonsense, but it's a code. Soha, sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. And toa, tangent is opposite over adjacent. Seriously, so, ka, toa is your new best friend. It's the key to solving pretty much any basic trig problem.
All right, we've got the language down. Now let's actually use it. The great thing about your exams is that you won't be asked about random angles like 27.3 degrees. No, you'll see the same special angles again and again, 30, 45, and 60 degrees. So let's master them.
The 45-degree angle is unique. In a right-angled triangle, if one of the sharp angles is 45 degrees, what does the other one have to be? Also 45 degrees. And that means the triangle is isosceles. The 2 shorter sides, the opposite and the adjacent, are exactly the same length.
And because those 2 sides are equal, look what happens to the ratios. They get incredibly simple. Since opposite and adjacent are the same, sine and cosine have the exact same value, 1 over root 2. And what do you get when you divide a number by itself? Just 1. So tan 45 is 1. These 3 values are non-negotiable. You just have to memorize them.
So what about 30 and 60 degrees? Where do their values come from? It all starts with a really clever trick. Imagine a perfect equilateral triangle, right? All its angles are 60 degrees. Now, what happens if we slice it straight down the middle? We get 2 perfect identical right-angled triangles, each with angles of 30, 60, and 90 degrees.
And that one simple trick gives us all of these values. But wait, look closer at the slide. Don't just memorize the numbers, look for the pattern. See how the sine of 30 is the exact same as the cosine of 60? And the sine of 60 is the same as the cosine of 30? They swap. This is not a coincidence, it's a huge shortcut. If you know one, you automatically know the other. It makes memorizing so much easier.
Okay, next up, we're going to connect everything we just learned to something you already know really well, the Pythagorean theorem. It turns out there's this powerful, almost hidden relationship between sine, cosine, and good old a squared plus b squared equals c squared.
And this isn't just some cool fact to note, this is a classic exam question. Understanding where this connection comes from is going to give you a huge advantage when you have to solve more complex problems.
Let's just walk through the proof right here. It's super simple. Step 1, we start with Pythagoras, but we write it out using the names of the sides. Now, step 2 is the big move. We divide every single thing by the hypotenuse squared. What happens? Well, in step 3, the right side just becomes 1, and the left side becomes 2 fractions, squared. Now for the magic. Step 4, what is opposite over hypotenuse? That's sine. And what is adjacent over hypotenuse? That's cosine. And that right there leads us to the most important formula, or identity, in all of trigonometry. For any angle A in a right triangle, sine squared A plus cosine squared A will always equal 1. This isn't just another formula to memorize, it's a tool. Think of it as your secret weapon for solving the tougher problems.
So we have covered a lot of ground. How do we pull all of this together into a simple strategy that's actually going to help you ace Chapter 8 on your exam? Let's build our master plan.
Here it is. Your entire plan for this chapter boils down to these 3 steps. Number 1, master the ratios. That means SO, COT, TOA has to be automatic for you. Number 2, memorize the angles table. You need to know the values for 30, 45, and 60 degrees without even thinking. And number 3, know your identities. Start with the most powerful one. Sine squared A plus cos squared A equals 1. If you focus your revision on just these 3 points, you'll be in fantastic shape for your exam. So as you're studying, just remember, you're not just memorizing formulas for an exam. You are learning a powerful language that acts like a bridge, connecting the visual world of shapes and geometry with the abstract world of algebra. It's a central pillar of mathematics for a very good reason.
So, I'll leave you with a final thought. Now that you have these basic tools to connect angles and sides, what else could you measure in the world around you? The height of a building? The angle of a skateboard ramp? Maybe even the path of a cricket ball? Keep this question in mind as you practice, and I promise you'll start seeing right-angled triangles absolutely everywhere. All the best for your exams.
Thank you for watching with us. See you next time.